Earth bears the scars of massive cosmic collisions, each one etched into the surface as a giant crater. Today we're going to count down 15 of the largest craters in the Earth. Starting with number 15, the Pinguitt Crater. Located in the remote Ungava Peninsula in northern Quebec in Canada, the Pinguitt Crater is a nearly perfect circular depression that spans almost 3.5 kilometers, or about 2.1 miles in diameter. It was formed about 1.4 million years ago during the Pleistocene epoch by the impact of a meteorite. This crater is among the best preserved impact structures on the planet, largely due to its isolated location. The name Pinguitt means where the land rises in the language of the local Inuit population. The crater does rise about 160 meters above the surrounding tundra and contains a lake, Lake Pinguitt, known for its exceptional clarity. With no inflowing or outflowing rivers, the lake is filled entirely by precipitation and snowmelt, giving it some of the purest fresh water in North America. Visibility in the lake has been measured at over 35 meters or 115 feet, and its maximum depth is about 267 meters or 876 feet. It drew scientific attention in the 1950s when researchers determined that it was meteoric in origin, based on the presence of impact-shocked rocks and the symmetrical bowl shape. Later studies confirmed that the structure had no volcanic origin and showed no evidence of tectonic subsidence. Now, what distinguishes it from many other impact craters is the state of preservation. Unlike craters in more temperate or tectonically active areas, Pinguitt has undergone minimal erosion since formation. The harsh environment here has effectively frozen the landscape in place, preserving geological features like raised rims, impact breccia, and fallback debris. In 2007, the area surrounding the crater was designated a national park by the government of Quebec, and the park covers about 1,100 square kilometers and it's co-managed with the Inuit community. It also serves as a natural climate archive of sorts. Core samples from the lake bed reveal layers of sediment that have accumulated over tens of thousands of years, recording past climate conditions in the Arctic. Despite its relative obscurity compared to other giant craters, though, this one's considered one of the most scientifically valuable. Its isolation, symmetry, and unaltered geology offer a glimpse into a moment of high-energy collisions frozen in time. Number 14. The Lonar Crater. The Lonar Crater is one of the few known hypervelocity impact craters formed in basaltic rock. Located in Maharashtra, India, it measures about 1.8 kilometers or 1.1 miles in diameter, and it's about 150 meters deep, that's 492 feet. Now, what makes it unique among terrestrial craters is the setting. It was formed in the Deccan Traps. This is a massive volcanic province composed predominantly of basalt lava flows. The impact event is believed to happen about 570,000 years ago based on isotopic dating of the rocks and sediments around the crater. The impact generated immense heat and pressure here, resulting in shock metamorphism and the formation of specialized minerals. Although the crater was known to local populations for centuries, the origin wasn't widely accepted until the early 20th century. In 1823, British officer J.E. Alexander documented the crater in detail, and subsequent scientific expeditions helped confirm that it was not volcanic in nature. Modern surveys, including magnetic and gravity, have further reinforced the impact hypothesis. The crater, though, is now partially filled by a saltwater lake known as Lonar Lake, which has highly alkaline and saline properties. Despite the extreme chemistry, though, it supports a unique ecosystem. Lonar Crater is also the site of historical and cultural interest. The region surrounding the crater contains numerous ancient temples, some dating back over thousands of years. These structures, often built in stone, show signs of weathering consistent with centuries of exposure to the region's climate. The Indian government and scientific institutions have conducted various studies on the crater's geology. Remote sensing from satellites, ground-penetrating radar, and sediment core sampling have all contributed to an understanding of the site. In 2020, the lake famously changed color from green to pink, likely due to an increased salinity and microbial bloom. That's a phenomenon that drew international attention and underscored the lake's dynamic nature. The crater is protected under Indian heritage and conservation laws, and tourism to the site has increased in recent years. The crater remains an active field site for both Indian and international researchers. It stands out not only for its origin and geology, but also for bridging multiple disciplines: planetary science, microbial ecology, and cultural history, all within a single impact site. Number 13. The Kara Crater. The Kara Crater is a massive ancient impact structure located in the Arctic region of northern Russia. Though heavily eroded and partially buried beneath layers of settlement and glacial deposits, the Kara Crater is considered one of the largest confirmed meteorite impact sites on Earth. Estimates of its original diameter range between 65 to 120 kilometers, that's about 40 to 75 miles, though erosion has obscured much of its initial structure. It was formed about 70 million years ago during the late Cretaceous period. The crater was first identified in the 1970s through a combination of aerial surveys, geological fieldwork, and remote sensing. It lies near the much smaller Tonguska Crater, which for a time was considered a separate impact site. Later analysis suggested it may actually be part of the same crater structure, possibly resulting from a fragmented meteorite impact. However, the current consensus is that Kara is the primary structure and Tonguska is a satellite feature. The impact that formed the crater would have released energy equivalent to millions of megatons of TNT. It likely caused a regional, if not global, environmental disruption. Although the timing is close to the Cretaceous-Paleogene boundary, the KP boundary, the period associated with the mass extinction of the dinosaurs, most geologists agree that Kara impact happened a few million years earlier and wasn't responsible for that extinction event. Geophysical methods like gravity and magnetic anomaly mapping have provided insights into the size and structure of the underlying impact basin. These surveys have identified a central uplift, ring faults, and other features consistent with large, complex craters. Rock samples taken from the site have revealed impact melt breccias, shocked quartz, and other diagnostic indicators of a high-energy impact event. Some of the ejecta and fractured rock zones associated with the crater extends for tens of kilometers beyond the main impact basin. Access, of course, is typically limited to the summer months via specialized Arctic expeditions. Nevertheless, it continues to be of major interest to planetary geologists, particularly those studying the Earth's large impact record and the environmental consequences. Its eroded and buried state is a reminder that even the largest scars on the planet can be slowly concealed by time. Number 12. The Manakawagan Crater. The Manakawagan Crater, located in central Quebec in Canada, is one of the most recognizable and best preserved structures on Earth. Its defining feature is a near-perfect annular lake called the Manakawagan Reservoir, which encircles the central uplift of the original crater and is clearly visible from above. The original impact structure is estimated to have been about 100 kilometers or 62 miles in diameter, though erosion has reduced the visible rim to around 43 miles. The impact happened about 214 million years ago during the late Triassic period. The crater was created when a large asteroid or comet, estimated to be about 5 kilometers or about 3 miles wide, struck the Earth at a high velocity. The force excavated a massive cavity in the Earth's crust and generated a rebound effect, forming a central peak that still exists. This central uplift is surrounded by the circular Manakawagan Reservoir, which was created in the 1960s after the construction of a hydroelectric dam system. The structure is classified as a complex crater, meaning it has a multi-ring basin and central uplift, characteristics common to large impact craters. Some early hypotheses link the Manakawagan impact event with a possible mass extinction event or with other large Triassic impact structures around the world as part of a proposed impact cluster. However, most scientists now consider it to be a singular, albeit massive event, without a clearly identified global extinction marker. In modern times, the crater's become more than just a scientific curiosity. The Manakawagan Reservoir, which now fills much of the crater basin, is part of Quebec's hydroelectric power plant network. The region provides renewable energy to millions of people and industries in the province. And the crater's also been the subject of comparative planetary studies. The preserved structures here make it an important analog for studying impact craters on the Moon, Mars, and other planetary bodies. Access to the site is possible by road, by boat, or by air, and the surrounding region is sparsely populated. It makes Manakawagan one of the few large craters that continues to evolve in both its geological and human context. This crater is not only a reminder of the violent cosmic history of the Earth, but also a demonstration of how ancient cataclysms can be integrated into modern life. Its appearance and geological clarity make it a cornerstone example in the study of terrestrial impacts. Number 11. The Chickixaloo Crater, the Yucatan Peninsula in Mexico. The Chickixaloo Crater is one of the most significant structures on Earth, not only because of its immense size, but because of its direct link to one of the planet's most profound events, the mass extinction at the end of the Cretaceous period. Located beneath the Yucatan Peninsula in Mexico, the buried impact structure is approximately 180 kilometers or 112 miles in diameter and was formed about 66 million years ago by a massive asteroid or comet estimated to be 10 to 15 kilometers, that's 6 to 9 miles in diameter. The crater itself is not visible at the surface today due to sedimentation and erosion over tens of millions of years. However, its circular shape and impact features have been confirmed through extensive surveys, including gravity mapping, magnetic studies, and drilling. Initial evidence for a global catastrophe came in 1980, when scientists Louis and Walter Alvarez discovered a worldwide layer of sediment enriched with iridium, a rare element often associated with asteroids. This layer, now known as the KP boundary, appears in geological records around the world, and it coincides precisely with the Chickixaloo impact. In the 1990s, geophysical data confirmed the presence of a large impact structure beneath Yucatan, providing direct evidence of the crater. Core samples taken from drilling projects, including the International Ocean Discovery Program's Expedition 364, have revealed shock quartz, melt rocks, and other features characteristic of high-energy impacts. Chickixaloo is a peak ring crater. This is a type of large impact structure with a central ring of uplifted rock surrounded by concentric rings and fault systems. Its unique geology allows scientists to study both the mechanics of planetary-scale impacts and the resilience in the face of extinction-level events. Today, the crater is the focus of multidisciplinary research across geology, planetology, climatology, and biology. Although largely hidden in the ground, it's reshaped our understanding of planetary impacts. Chickixaloo is a silent marker of both destruction and the eventual renewal of life. Number 10. The Vetofort Crater, Free State, South Africa. The Vetofort Crater in South Africa is the largest confirmed impact structure on the planet. It's located in the Free State province and has an estimated original diameter of 250 to 300 kilometers, that's 155 to 185 miles. Formed approximately 2 billion years ago during the Paleoproterozoic era, it's one of the oldest known impact craters. Although much of the structure has been eroded over time, the central uplift, known as the Vetofort Dome, is still visible, and it serves as a feature of the region. The impact that created the structure was caused by an asteroid estimated to be at least 10 kilometers or 6 miles in diameter. The force of this collision would have vaporized the surrounding rock and penetrated deep into the Earth's crust. Shockwaves from the impact fractured the bedrock and created a multi-ringed basin, similar to those seen on the Moon and other planetary bodies. Over the next 2 billion years, tectonic activity and erosion erased much of the outer crater, leaving only the deeply eroded core visible. The dome consists of concentric rings of metamorphosed and deformed rock layers, many of which were originally horizontal but were uplifted and bent by the force of the impact. The innermost rocks, including ancient granite and greenstone belts, are over 3 billion years old, making them among the oldest exposed rocks on the planet. Because of its age and its state of preservation, Vetofort provides a rare opportunity to study the deep crustal effects of large impacts. It also serves as the benchmark for understanding a multi-ringed basin formation on Earth and other planets. The crater has played an important role in South Africa's economic history. The surrounding Witwatersrand Basin, affected by the impact, contains the majority of the world's known gold reserves. Though the gold was deposited before the impact, the event may have influenced the structure and concentration of ore-bearing rocks. Modern research here involves a combination of fieldwork, satellite imagery, and subsurface modeling to reconstruct the original structure. Studies of shocked minerals and impact melt rocks continue to refine the understanding of how the Earth's crust responds to these large-scale extraterrestrial collisions. Although the crater is not fully visible at the surface due to erosion and geological activity, its central uplift, spanning nearly 70 kilometers or 43 miles, remains one of the clearest and largest impact-related structures accessible to scientists and the public. Number 9. Gosss Bluff, the Lonar Crater. Gosss Bluff, known as Tunorala in the language of the Western Arunte people, is a striking circular formation located in the remote MacDonnell Ranges of Central Australia. The current structure measures about 5 kilometers or 3.1 miles in diameter and rises about 180 meters or 590 feet above the plains. However, geological studies indicate that the original impact crater was larger, about 22 kilometers, about 14 miles across, before erosion reduced it to the prominent central uplift visible today. The impact that created the bluff happened around 142 million years ago, during the early Cretaceous period. It was caused by a comet or an asteroid estimated to be about a kilometer in diameter. The force of the impact compressed the Earth's crust and caused a central rebound, forming an uplifted dome of rock that now dominates the landscape. What remains today is a textbook example of a central uplift, the inner zone of a complex impact crater, making Gosss Bluff a site particularly interesting to planetary geologists. Shatter cones and shocked quartz have been found at the site, both of which are diagnostic indicators of a meteorite impact. The site was first identified as a potential impact crater in the 1960s. It's now recognized as an internationally well-preserved impact structure and an analog for similar features observed on Mars and the Moon. But beyond its scientific value, Gosss Bluff holds a deep cultural significance for the people. According to Dreamtime stories, the formation was created when a group of celestial women danced across the sky. One of them placed her baby in a wooden basket, Turna, which fell to the earth and created the circular mountain range upon impact. The Tnorala site is regarded as sacred, and access is controlled with indigenous custodians. Today, the bluff lies within a conservation reserve managed by the Northern Territory government. The area offers interpretive signage and a viewing platform to appreciate the formation without disturbing it. Gosss Bluff exemplifies how an impact structure can evolve over time, yet still retain clear evidence of its origin. Number 8. Clearwater Lakes Crater. The Clearwater Lakes Crater, located in the region of northern Quebec in Canada, consists of two adjacent circular lakes, Clearwater Lake East and West, each occupying a separate impact structure. The two craters differ significantly in age and size. Clearwater West is the larger and older of the two, with a diameter of about 22 miles and an age of about 290 million years. Clearwater East is about 16 miles in diameter and was formed roughly 460 to 470 million years ago. For a time, the close proximity of the two craters led to speculation that they were created by a binary asteroid impact, a rare event in which two gravitationally bound asteroids strike the Earth simultaneously. However, radiometric dating has confirmed that the two craters were formed by separate impacts, happening nearly 200 million years apart. Clearwater West displays classic features of a complex crater. It includes a central uplifted peak, ring structures, and a well-defined circular outline. Clearwater East is more eroded and less prominent, with a shallower basin and less well-preserved structure. Both craters were carved into the Canadian Shield, an ancient geological formation composed primarily of Precambrian igneous and metamorphic rocks. The immense pressure and heat from these impacts fractured and melted these rocks. Drill cores taken from both sites confirm their origins and provide a stratigraphic record of the impacts. Despite the inaccessibility, the Clearwater Lakes have been extensively studied by geologists, especially during the mid to late 20th century. NASA scientists and planetary researchers have used the sites to understand crater formation. And in addition to the geological value, the lakes are part of the traditional territories of the Cree and other indigenous peoples, who have long known and utilized the surrounding lands. The lake supports freshwater ecosystems and are occasionally visited by anglers and eco-tourists, though conservation rules limit development in the area. The clear water, the symmetrical shapes, and central islands makes these features easily visible in satellite imagery, and they serve as important analogs for understanding impact events on the Earth and other planets. They remain among the most photogenic and well-preserved impact structures in North America. Moving on to number 7, Wolf Creek Crater. Wolf Creek Crater, known as Kandamalal to the Aboriginal people, is one of the best preserved meteorite impact craters on Earth, and one of the few select large craters that's easily visible and accessible at ground level. Located in the Great Sandy Desert of Western Australia, it's got a diameter of about 875 meters or just over 2,800 feet, and a depth of about 60 meters or 200 feet. The crater was formed by the impact of an iron meteorite roughly 300,000 years ago during the Pleistocene epoch. It was first discovered by scientists in 1947 during aerial surveys. It had long been known to the Aboriginal peoples, whose oral traditions included stories that relate to its sudden creation. While those stories predate scientific explanation, they remarkably align with the concept of a fiery object falling from the sky. The name Wolf Creek comes from the nearby Wolf Creek, named during the 19th century explorations of the region. The meteorite that created it is believed to have been composed mainly of iron and nickel and was likely 15 meters or 50 feet in diameter when it struck the Earth. The impact would have released the energy equivalent of about 1 to 2 megatons of TNT. That was enough to vaporize the meteorite and excavate a deep circular hole. Investigations have yielded some significant findings. Fragments of the original meteorite have been found both within the crater and scattered in the surrounding desert. These fragments are composed of metallic iron with high concentrations of nickel, typical of meteorite material. The crater's location, about 150 kilometers south of Halls Creek in Western Australia, has helped preserve the form. Unlike older craters that have been heavily eroded or buried, Wolf Creek still exhibits clear raised rim structures and radial ejecta patterns. These features make it a valuable site for geological field studies and a popular destination for visitors. Wolf Creek is protected as part of Wolf Creek Meteorite Crater National Park that was established in 1969. Basic trails allow visitors to approach the crater rim and observe the geological characteristics up close. In the Aboriginal culture, the crater is associated with the rainbow serpent, a powerful being in many Dreamtime stories. The Jaru people explain the crater's origin as the place where the serpent emerged from the ground, linking it to a wider indigenous cosmology. These perspectives are now formally acknowledged in site interpretation and preservation efforts. As one of the few large craters that can be visited easily, it serves as a reminder of the powerful extraterrestrial forces that continue to shape our planet. Number 6. Pinguitt Crater. The Pinguitt Crater in Siberia is one of the largest and significant impact craters on Earth. It's located in a remote part of the Krasnoyarsk Krai. The structure measures about 100 kilometers or 62 miles in diameter and was formed roughly 35 million years ago. It was created by the impact of an asteroid, estimated to be about 5 to 8 kilometers or 3 to 5 miles in diameter, that struck the Earth at a high velocity. What makes it notable is the geology of it. The region where the impact happened contains large quantities of graphite-rich rock. When the asteroid struck, the extreme pressure and heat converted this graphite into diamonds. These impact diamonds, which are typically 0.5 millimeter to 2 millimeters in size, are often riddled with inclusions and imperfections. In some cases, much larger diamonds have also been recovered from the site. Soviet geologists confirmed the impact origin of the crater in the 1970s, though its remote location, about 300 kilometers from the Arctic Ocean, has limited any on-site explorations. This crater exhibits many classic features of a large, complex impact structure, including a central uplift, multi-ring basin, and extensive breccia and melt rock depositions. The diamond deposits have led to commercial interest, of course, particularly during the Soviet era. However, the industrial potential has never fully been realized due to the logistics. Nevertheless, the crater remains a scientifically valuable site for studying high-pressure geology. In recent years, there's been renewed interest in the diamonds here and its role in Earth's impact history. Some researchers have suggested that the impact may have contributed to a minor extinction event, although this remains a topic of ongoing study. There's no confirmed link between the impact and any global catastrophe, but the scale and energy suggest it would have had significant regional effects, including wildfires, atmospheric dust loading, and climate shift. Because of its size, preservation, and the presence of shock-induced diamonds, Pinguitt is frequently compared to other major impact structures like Chickixaloo and Manakawagan, yet its Arctic setting and geological distinctiveness make it a singular location in the study of cratering. It stands as a colossal geological feature, preserving the violent moment when a celestial body forever altered the composition of an entire region. Number 5. The Behringer Crater. The Behringer Crater, commonly known as Meteor Crater, is one of the most well-preserved and studied meteorite impact craters on Earth. It's located in the northern desert near Winslow. The crater is about 1.2 kilometers or 3/4 of a mile in diameter and about 170 meters or 560 feet deep, with a rim that rises 45 meters or 150 feet above the plains. It was formed roughly 50,000 years ago by the impact of a nickel-iron meteorite roughly 50 meters or 160 feet in diameter. Despite its relatively small size compared to other craters on this list, Behringer Crater is significant because of its exceptional preservation. The desert location has protected it from erosion, glaciation, and vegetation overgrowth. The crater's structure includes a clearly defined ejecta blanket, overturned strata on the rim, and shatter cones, conical fractures in rock caused by shock waves. The crater is named after Daniel Morrow Behringer, a mining engineer and entrepreneur who in the early 20th century was the first to seriously propose that the structure was the result of a meteorite, rather than volcanic activity. Behringer invested heavily in drilling operations to locate the meteorite and to mine what he believed would be valuable iron deposits. While he never recovered the meteorite core he expected, his theory was eventually validated. Scientific investigations have shown that the meteorite that caused the crater weighed about 300,000 tons and was traveling at a velocity of about 12 to 20 kilometers per second. That's about 26,000 to 45,000 miles an hour at the time of impact. The collision would have released the energy equivalent of about 10 megatons of TNT. That's about 600 times more powerful than the bomb dropped on Hiroshima. The impact vaporized most of the meteorite and it excavated millions of tons of rock. Fragments of the meteorite, known as Canyon Diablo meteorites, have been found in abundance around it. These fragments consist mainly of iron and nickel, and some of them are on display at the visitor center near the crater rim. Today, Behringer Crater is privately owned by the Behringer family and maintained by the Behringer Crater Company. It is a designated national natural landmark and a major educational and tourist destination. It's a classic example of how a small but well-preserved impact site can revolutionize our understanding. It's often the first impact crater that students of planetary science learn about and continues to provide insights into the mechanics of high-velocity collisions. Number 4. Zaman Shin Crater. The Zaman Shin Crater, located in the Aktobe region of western Kazakhstan and is one of the youngest large impact craters on the planet. It measures about 14 kilometers or 8.5 miles in diameter and was formed around 900,000 years ago during the late Pleistocene epoch. The impactor is estimated to have been a stony asteroid several hundred meters in diameter, which exploded with enough energy to leave behind a complex crater structure. What makes it notable is the potential link to atmospheric and environmental consequences on a global scale. Although the impact wasn't large enough to cause a mass extinction, some scientists suggest it may have produced a regional or hemispheric climate disruption. This in part due to the release of fine dust and aerosols into the atmosphere. The crater features a multi-ring structure typical of complex craters with a low central uplift and a flat inner basin. Studies have revealed a buried central peak and a well-preserved rim beneath the surface sediment. This one also has a rare combination of impact-related minerals, including shocked quartz, tektites, and impact glass. These glassy fragments were formed by the rapid melting and ejection of target rock during the impact event. Some resemble North American tektites found near larger impact structures like the Chesapeake Bay, though this one's materials are locally distinctive and has been classified as ergazites. These have been studied for clues about the energy of the impact and the atmospheric chemistry that followed. Core samples and radiometric dating have helped to refine the crater's age and confirm the impact origin. Unlike many older or more eroded craters, this one retains clear stratigraphy and impact layers that allow for detailed reconstruction. The surrounding region is largely flat and semi-arid, and the crater itself is not immediately obvious from the ground without geophysical or satellite data. However, remote sensing has confirmed its circular outline and impact-related anomalies. The crater continues to attract attention from geologists, impact specialists, and planetary scientists, especially those studying mid-sized craters and their consequences. This one provides crucial data in understanding the threshold at which impact events can influence climate without causing mass extinction. It shows how even smaller-scale collisions happening in the recent geological past can leave lasting geological signatures. Number 3. Elgagitkin Crater. The Elgagitkin Crater, that's pronounced Elgagitkin, it's located in the remote autonomous Okrug region in northeastern Siberia in Russia. It measures about 18 kilometers or 11 miles in diameter and was formed around 3.5 million years ago during the Pliocene epoch by the impact of a meteorite that struck a region composed mainly of volcanic rock. Unlike many other craters that have been partially eroded or buried, Elgagitkin is particularly well preserved and contains a deep lake that has never been glaciated since its formation, making it an exceptional site for both impact science and climate research. The name Elgagitkin comes from the Chukchi language and means white lake. The lake at the center of the crater is roughly 12 kilometers or 7.5 miles in diameter and reaches depths of about 175 meters or 574 feet. Because of its high latitude, located within the Arctic Circle, and cold, isolated setting, the lake and its surrounding sediments have remained undisturbed by glacial action. This makes Elgagitkin one of the few locations in the Arctic where a continuous sedimentary record is going back millions of years. In 2009, an international research team led by scientists from Russia, Germany, and the United States conducted the drilling project there. They drilled a core more than 400 meters into the lake and an additional 200 meters into the impact structure beneath. From the lake bed, scientists extracted a continuous climate record spanning the last 3.6 million years, a unique data set for the Arctic region. This has allowed researchers to study the past temperature fluctuations, ice cover history, and climate transitions, including any interglacial periods. Despite being less dramatic in the surface appearance than craters like Behringer or Chickixaloo, Elgagitkin is more valuable for the preserved subsurface data it contains. It also hosts a limited number of cold-adapted species, including some endemic fish, and it's one of the few large Arctic lakes unaffected by humans. The region remains uninhabited and difficult to access, requiring extensive logistics even to reach it. Elgagitkin represents a rare convergence of impact geology and long-term climate science. It's helped researchers draw comparisons between Earth's impact history and that of other planetary bodies. Few other sites provide such multidisciplinary value within a single geological structure. Number 2. Bosamui Crater. Located in the Ashanti region of central Ghana, the Bosamui Crater, the only confirmed impact crater in Ghana and one of the best preserved young impact structures in the world, was formed about 1.7 million years ago during the Pleistocene epoch. The impactor struck hard crystalline bedrock and produced a complex crater with a central uplift that is now submerged. The lake is circular and about 5 miles across, with a maximum depth of around 80 meters, that's 260 feet. Its formation is remarkable given the tropical climate and relatively high rainfall in the region. Unlike many craters that have been filled in or obscured, Bosamui retains its distinct shape and structure. The presence of shocked quartz, impact breccia, and suvite, a type of rock formed by the fusion of molten fragments, confirms the crater's impact origin. The sediment layers reveal variations in precipitation, vegetation, and dust deposition, contributing valuable information to the study of monsoon dynamics and long-term climate change. In addition to its scientific significance, the lake holds some cultural importance for the Ashanti people. It's considered sacred, and traditional beliefs hold that the souls of the dead come to the lake to bid farewell to the earth. These cultural practices have helped limit any modern disturbance to the lake, which preserves its geological integrity. Studies of its structure and the distribution of ejecta have helped improve the models of impact processes in various target rock types and environmental conditions. Remote sensing, ground-based geophysics, and subsurface drilling continue to refine our understanding of its formation. Unlike many other craters, it's both easily accessible and minimally disturbed, making it ideal for repeated study. The lake and its crater stand as a powerful example of how a catastrophic event from deep space can create not only a geological landmark, but an enduring natural and cultural feature. Number 1. The Tonguska Event Site. Come on, we all knew it was going to be this one. While not a traditional impact crater, the site of the Tonguska event in Siberia represents the largest known Earth impact ever recorded. In the morning of June 30th, 1908, a massive explosion flattened about 2,100 square kilometers or 830 square miles of forest. The blast is believed to have been caused by the atmospheric entry and subsequent airburst of a small asteroid or comet, estimated to have been about 50 to 60 meters, 160 to 200 feet in diameter. The explosion released the energy equivalent to 10 to 15 megatons of TNT. But despite the immense devastation, no impact crater was ever found, and no fragments of the impacting body have been definitively recovered. This has led to extensive investigation and, for many years, widespread speculation. The first formal expedition to the region happened in 1927, led by Soviet mineralogist Leonid Kulkik. His team observed millions of trees laid flat in a radial pattern from a central point, with those near the epicenter scorched but still standing upright, resembling telegraph poles. This pattern supported the hypothesis of a high-altitude explosion rather than a surface impact. Later research confirmed that the explosion had happened between 5 to 10 kilometers above the ground. Although various alternative theories have circulated over the decades, including volcanic eruptions, antimatter, and even alien spacecraft, peer-reviewed scientific consensus attributes the Tonguska event to a stony meteoroid or comet. This explanation is supported by computational models, eyewitness reports, and aerial surveys of the damage pattern. In 2007, a joint Italian-Russian team claimed to have found evidence of a small impact crater in Lake Checo, about 8 kilometers from the epicenter, suggesting it may have been created by a fragment of the original object. Most experts still maintain that the explosion happened entirely in the atmosphere and didn't leave behind any traditional craters. The Tonguska event is unique, not only for its scale and location, but also for the absence of any fatalities, despite its magnitude. The event is often cited as a case study in planetary defense, illustrating the destructive potential of even relatively small near-Earth objects. Today, the Tonguska site is part of a protected nature reserve, though recent advances in satellite imagery and remote sensing have allowed for more detailed study. The event also inspired early 20th century interest in planetary threats. The Tonguska event site, despite the absence of a visible crater, ranks as the most powerful extraterrestrial impact in modern times, and it stands as a reminder of Earth's vulnerability to cosmic events.